Hello, scholars, and welcome to this video where we'll be working on some time value of money discounted cash flow valuation practice problems. Let's start with present value of uneven cash flows. Suppose you're looking at the following possible cash flows. The required discount rate is 7%, and you have a cash flow in year one of 100, year two of 200, year three of 300, year four of 400. So the way I like to solve these is to take the financial calculator and notice this CF button for cash flows. And in here, press cash flows, then second, clear work. That'll zero out all the entries within there. Cash flow zero, we're going to leave it zero because there's no cash flow specified right now today. We're going to scroll down at the top row there to cash flow stream one, and that's 100. Enter. Then we're going to scroll down. It's going to prompt us for the frequency of that stream, and that's going to be 1. We just get that 100 one times. And then cash flow 2 is 200. Enter. If you left this at 1, you're all set. Cash flow 3, that's 300. Enter. Down, and cash flow frequency of cash flow 3 is 1. Cash flow 4 is 400. Enter, and then compute up here in the upper left. Then NPV, we've given it the timing of cash flows and the magnitude of cash flows. Now the calculator is going to prompt us for some proxy of risk because timing, risk, and magnitude is the basis of all financial valuation. And our interest rate here is 7, our discount rate. Enter. Your calculator knows that that's a percentage, so just go ahead and type in 7. Enter. Down, and then compute, and you get the answer of $818.19. So again, this was what we did. We did cash flow 0, then we entered this as cash flow stream 1, cash flow 2, cash flow 3, cash flow 4, and each of those had a frequency of 1 only because we're getting them each one time. Okay, future value of uneven cash flows. Let's say you deposit 100 into an account in 1 year. Let's just set up a timeline because this can get a little tricky. In 1 year, you deposit an account 100. At time 2, nothing happens. At time 3, you're going to deposit 300. How much will be 5 years? So the first thing to notice is this first cash flow will actually compound 4 times. If you receive it in 1 year and you save it, you compound it once, twice, 3 times, 4 times. So the way I'm going to solve that is with N, IY, PV, payment, and FV. So to get to this, N is 4. IY is 8. Your present value is 100. There's no payment between now and then that is fixed and finite. There's no annuity payment. So I'm just going to compute that future value. So I'm going to type in 100 for my present value, 0 for my payment, 8 for my IY, 4 for my N. And I think that's where students will get a little bit tripped up. And then compute for the future value. That's going to come out negative. Well, it looks like we forgot one. 4N, 8IY, 100 payment, 100 present value, 0 payment, and then we're going to compute for our future value. So our future value should actually be positive, so we're just going to write 136.05. If you want to save that number, you can press STO for store, and then put it in the first component, store 1. All right, the next cash flow we need to value is the 300 to find its time 5 value. So if we receive it in 3 years, it only gets 2 compounding opportunities. It's going to compound twice. So our N for this cash flow is 2. Our rate is still 8. Our payment is 0. And our present value is 300. And we're going to compute for that future value and then add it to the first one we calculated. So 2 and 8 IY, 0 payment, 300 present value, and then compute for your future value. Again, just ignore that negative. That's our value of the second cash flow. And then we're going to add that to the answer we had before of 136, and we'll get to our total answer of $485.97. And that's just valuing two different cash flows. Be careful with the timing. It would be quite easy to make a mistake on that one. Present value of an ordinary annuity with annual payments. So remember, an annuity has cash flows that are fixed amount for finite time. And this is telling you it's a fixed amount of $12,000 per year. That's your payment amount, PMT payment, 12,000. Its annual payments, our time is 6, our interest rate is 8. And when we're calculating the present value of these, we're going to set the future value equal to 0. One way to think about that is if this is today at time 0, and this is time 1, 2, all the way up through 6, we are just valuing the 6 payments of 12,000. There's no additional lump sum out here. So we're going to set our future value at 0. So when we prompt the calculator, it's just picking up 6 periods of a payment of 12,000 and nothing else. So that's why the future value needs to be specified at 0. All right, so we've had all that incorrectly. So 12,000 is your payment. 6 is N. 8 is your IY. 0 is your future value. And then in the upper left, press compute for your present value. And again, ignore that negative, or you could just think of it, you'd have to spend $55,000 today as a cash outflow in order to receive the payment stream of $12,000 a year for 6 years. So that's the answer, $55,474.56. Let's look at the future value of an ordinary annuity with annual payments. You've decided to save $7,000 per year into a Roth, and that's currently the maximum, so good on you. You're going to do this for 40 years. Assume you start saving at the end of the year. That part is just specifying that it's an ordinary annuity, and the vast majority of these that you'll see are indeed ordinary or regular annuities. So our payment, again, is annual, so we just have a payment of $7,000 per year for 40 years. Our rate is 10. Our present value is 0. There's no starting balance. You're just going to value the future value of these $7,000 per year payment for 40 years. So that can be a little bit tricky. And then we're going to compute for a future value. So 7,000 PMT payment, 40 end periods, 10 interest rate, 0 present value, and now we'll compute for the missing one, which is future value. That's $3 million. So I think that could be very doable, something definitely to shoot for if you're hoping to be a millionaire. So don't just work through these trying to get the correct answer all the time. Use this to build some intuition and hopefully build some better habits in terms of saving for your future self. All right, finding the future value. Let's just write that out. That's 3,098,147. I love questions like this one. All right, finding the future value of an ordinary annuity with monthly payments. Now, when you get a question with monthly payments, you need to be very, very careful in terms of timing, risk, and magnitude. All 3 of those measures need to be valued consistently on a monthly basis now. So we're going to save $100 per month. That's our payment. So I'm going to write payment is 100. And I like to write the units out here. That's $100 per month, starting at the end of the month. That's telling us it's an ordinary annuity for 40 years. So you just have to take 40 years times 12 months per year to get to the number of months. And then your interest rate also needs to be converted into a monthly basis. This is an annual percentage rate. It just specifies that it has monthly compounding. So you have to take that annual percentage rate of 8, divide it by 12 months per year, and now you'll be left with a rate per month. How much will this be worth in 40 years? Set the present value equal to 0 and then compute for the future value. Again, we're just going to value the payments of 100 per month for this amount of time. Before I calculate the future value, I like to do a double check that I have consistently measured timing, risk, in magnitude consistently on a monthly basis. That's why I like to write the units out on something that is a frequency other than annual. So 100, then payment, 40 times 12. Make sure you press equals first before you pressing N. 8 divided by 12 equals, again, then IY. I'm not doing any rounding in here. 0 PV, and then compute for your future value. And that does look correct. $349,000, 178. Wonderful. All right, understanding a loan. So we're going to have an ordinary annuity with monthly payments. You've just closed on a new home. A loan on a home is called a mortgage. Now you have a 30-year, 300,000 mortgage with a contract rate of 6%. What's your monthly payment? Let's solve that part first. So again, it's monthly, so we have to be careful here. Time is 30 years times 12 months in a year for 360 months. Timing, risk, or IY, that's an annual rate. Conventionally, we quote rates annually. So you can expect to see in a question rates given on an APR basis, and you have to convert it to a rate per period. So 6 annual rate divided by 12 months in a year will get you to a rate per month. Then when you compute for payment, the amount will come out as an amount per month. The value of the home is 300,000. That's your present value. You're going to pay that off to a future balance of 0. So set your future value to 0 in this case. So 330 times 12 is 360 and months. 6 over 12 is 1/2 rate, IY. 300,000 present value and then 0 for your future value. And now you can compute for your payment. Your payment in this case is going to come out negative because you have the benefit of living in the home. So you receive a $300,000 home, but now you need to make a payment of $1,798.65. It would get you the same answer if you typed in a negative present value, then your payment would come out positive. Think of that as the bank's perspective. They paid for your home and now they will receive the payment for the next 360 months. How much interest? What is the total interest you will pay over the life of the mortgage? So if we take a look, our total payments in this question will be 360 months of payments times 1798.65 per month. That's the total payments. So we'll take this amount, it's already in our calculator there, and multiply by 360. That represents the total amount you pay for the home. So that's 647,514. Why is it so much higher, you ask? That's a great question. Well, 300,000 of it is principal. Any additional beyond that is interest. So if we subtract the principal, the change in principal, which in our case was 300,000, the remainder is interest. So your total payments minus your change in principal will get you to your interest. So your principal is the starting balance. So we're going to deduct that 300,000. And in interest, you will end up paying $347,514.57. Finding the present value of an ordinary annuity with annual payments. Your eldest daughter, Belle, will start attending the University of Cincinnati in 1 year. Go Bearcats. Fees will be $50,000 per year for 4 years, starting 1 year from today. Assuming the interest rate is 8.5%, how much do you have to save today? So she's going to start in 1 year. That's just telling you it's an ordinary annuity. The amount of the payment is $50,000. Your interest rate is 8.5%. There's no need to do an adjustment here because we have annual payments for 4 years. So our time is 4. Your future value is 0. Beyond the 4 payments of $50,000, there's no additional payment. There's no money paid for or received at the end beyond these. So you can set your future value at 0. So 50,000 is your PMT payment. 8.5 is your IY. Again, your calculator knows that's percentage form. 4 is N. 0 is your future value. And then we're going to go ahead and compute for the present value. That's the amount of money you need to contribute today in order to pay for the education fully funded. $163,779.83. Now, finding the present value of a delayed ordinary annuity. Now, your newborn daughter, Lena, will start attending the University of Cincinnati 18 years from now. So draw a timeline on a question like these because they can be quite tricky. This implies that there's 17 years of no payments happening. At time 18 and then 19, 20, and 21 is when the payments will occur of 50K. Now here's a little shortcut to solve this one. Notice there's no cash flow here, so you could set your first cash flow 0 equal to 0. Your next stream of cash flows or your next pattern of cash flows is cash flow stream 1. That's 0 for a frequency of 17. There's 17 times where no payment is occurring. And then your next pattern or stream of cash flows, cash flow stream 2, is 50,000. And that would have a frequency of 4. So we can use this uneven cash flows approach to value a delayed annuity. So press cash flow. There's numbers already in that entry. So press second on the left-hand side and then clear work at the bottom left. Cash flow 0 set at 0. Scroll down to cash flow stream 1. Set that equal to 0. Enter. Down. It has a frequency of 17. It's one less than when the first payment starts. The first payment here starts at time 18. So we have 17 years of no payments. Be careful on that question. Make sure you pause and remember that. Scroll down to cash flow stream 2. This pattern is 50,000 per year. Enter. Scroll down. Your daughter Lena, you expect to be in college for 4 years. So the frequency of that 50,000 is 4. Now compute net present value. We've given it the timing and the magnitude of cash flows. Now we need some kind of estimate for risk, which will be 8.5%. So 8.5. Enter, down, and then compute. You would need to set aside 40,000. Notice you need to save less today because those cash flows aren't occurring until the future. And that's exactly what we had here. 40,921.81. The present value of a perpetuity is next. You want to endow an annual graduation party at your alma mater. Let's go Bearcats. You want the event to be a memorable one, so you budget 30,000 per year. So that's an annuity that continues forever. That's called a perpetuity. If the university earns 8% per year on its investments and the first party's in 1 year's time, how much do you need to donate today to endow this party every year? So here's the formula. The present value equals the payment C over R. So this is a perpetual stream of cash flows, never ending. They're always going to party in your name now. So the present value equals 30,000 per year. We're using a formula with an interest rate, so we need to move the decimal place here. So if it's 8%, we have to convert that to decimal form by moving that decimal place 2 places. So 30 over 0.80 will get you the amount you need to invest. So 30,000 over 0.08 equals 375,000. So if you donate this amount today, then you can have a party in your name forever. That's the amount of 30,000. That'd be a pretty cool party. Let's see how this works though. If you multiply this investment, if that's the amount you're saving, in 1 year's time, that'll compound at a factor of 1 plus R. So multiply that by 1.08. In 1 year, that saving will be worth $405,000. Then you spend it. So I'm going to subtract 30,000 on the party. And you're right back to that initial investment. So essentially, you're partying off this initial investment's interest every year. Now, for the payment of a perpetuity, you just won the lottery and you want to endow a professorship at your alma mater, perhaps your favorite finance professor. Wink, wink. You are willing to donate 4 million of your winnings for this purpose. The university earns 5% per year on its investment, and the professor will be receiving her first payment in 1 year. How much will the endowment pay her each year? So your present value equals C over R again, but in this case, you are given the present value of 4 million. That's the amount you're willing to invest today for your present value. So the amount of the payment is the salary divided by the discount rate, 0.05. So all we have to do here is multiply both sides by 5%. So take the 4 million times spot zero five equals the salary of 200,000. Not too shabby. All right, thanks for this video. It was wonderful to work on this with you. I hope you found it helpful.